Hello, I'm ETarte, math teacher. This is a solution video to my math challenge entitled Slide That Triangle. In that challenge I said we start with an equilateral triangle ABC with base BC being horizontal. We slide that triangle down vertically, forming the new triangle DEF, congruent to the original triangle ABC. And we slide it exactly the amount so that the area of that smaller triangle DGH is exactly half the area of triangle ABC. And I had two questions. First question, if the distance that we slide it down is the square root of 3, shown here as a perpendicular distance between the parallels, if that distance is the square root of 3, then what is the area of triangle DGH, that is the shaded area? And my second question, generalizing, if the distance we slide it down is x, then what is the area of triangle DGH, that is the shaded area, in terms of x? Well, there's more than one way to do this. I will go over the way that works for me, and it probably, in my opinion, doesn't matter which question we try to answer first. I will first answer the question in which the distance is the square root of 3. Well, it's a fact of geometry that if you have two similar figures, meaning two figures with the same shape, the ratio of their areas is the square of the ratio of corresponding lengths, corresponding distances. For example, this represents first 9 congruent rectangles arranged in this rectangle with area 9, and then 4 of them arranged in the smaller rectangle with area 4. The ratio of their areas is 9 to 4, but the ratio of their lengths and the ratio of their heights is 3 to 2. We see that ratio 3 to 2 horizontally and also vertically. So the ratio of corresponding lengths is 3 to 2, and that ratio of areas 9 to 4 is 3 to 2 squared. Well, since this challenge is about triangles, I offer you one more example. Two similar triangles. This one has 9 triangle areas, 1, 2, 3, 4, 5, 6, 7, 8, 9. This one has 4 of the triangle areas, so the ratio of the areas is 9 to 4, but the ratio of corresponding lengths, we can see that horizontally here, is 3 to 2. Now in our challenge, consider the heights of triangle DGH and of triangle DEF, DEF being congruent to ABC. The height of triangle DBH I'm calling N, and the height of the red triangle DEF is then N plus root 3. By that rule about the ratios of corresponding lengths and ratios of areas, that ratio, the ratio N plus root 3 over N squared, equals the ratio of the two areas, which, as given, is 2 to 1. I take the square root of both sides of that equation. The exponent squared disappears, and I have N plus root 3 over N equals the square root of 2 over the square root of 1. The square root of 1 is still 1. I multiply both sides of that equation by N, and I get N root 2 equals N plus root 3. I subtract N from both sides of the equation. I get N root 2 minus N equals root 3. On the left side, I factor out the common factor N, and I have N times root 2 minus 1 equals root 3. I divide both sides by root 2 minus 1, and I have N equals root 3 over root 2 minus 1. We can simplify this value of N by getting rid of the root sign of the denominator. The method for doing that is to multiply numerator and denominator by root 2 plus 1. When we do that and we FOIL the two denominators, we get 2 minus 1, which is just 1. So with denominator 1, we drop the denominator, and we find that n equals root 3 times root 2 plus 1. Now we look at triangle GDI. It is a 30-60 right triangle, and because of that, the length GI is that length n divided by root 3. And so GI is root 2 plus 1. Now the area of a triangle is 1/2 its base times its height. GI is 1/2 the base of triangle DGH, so the area of triangle DGH is simply GI times DI, that's GI times n, that's root 2 plus 1 times root 3 times root 2 plus 1. When we FOIL these, we get 3 plus 2 root 2. So the area of triangle DGH is root 3 times 3 plus 2 root 2. To answer the second part of the challenge, we replace root 3 by x in this process, and the process is very similar to this. The bottom line there is that we get the area of triangle DGH in terms of x equals x squared root 3 times 3 plus 2 root 2 over 3. So that is my solution to my math challenge, Slide That Triangle. Thank you for watching this solution video.